In this video, we're going to learn how to find the inverse of certain trigonometric functions. So before we study that, let's recall how we define those inverse trigonometric functions. So one of the problem that we have is we know that the trigonometric functions are periodic functions. That means if you pick a value in the range, there are multiple values mapping to that from the domain. Just to avoid the difficulty or for example not being one-to-one, what we try to do is we restrict the domain of the we restrict the range of the sine inverse function. So for example, so what we did for the sine, the y value, so this is the x value and the y value. So what we did, we know that the x values are the values you plug in, so that means those values should be between 1 and -1. The same thing is valid for the cosine function. So what happened? So what we did, we restrict the range of the sine inverse function from negative pi over 2 to pi over 2 to make it a one-to-one function. So that means y values of the sine inverse function, or that means the range is going from negative pi over 2 to positive pi over 2. And for the cosine inverse, the x values, for sine inverse, the x values are going to be, or the domain is from -1 to 1. So the same thing for cosine, so the domain is again from -1 to 1. But the range we define as going from 0 to pi. So going from 0 to pi. So the easy way to remember this is you can see the sine function is the range of the sine function, sine inverse function is defined where the cosine is positive. So you can see that if you look at the range of the sine inverse function, that's where the cosine is positive. And if you look at the range of the cosine function, those are the values this where the sine positive. So that's the easy way to remember. And then if you go to tan inverse, so you can see tan inverse, the values range from -infinity to positive infinity. The range going from negative pi over 2 to positive pi over 2. So y is going from positive pi over 2 to negative pi over 2, excluding the corners. And the x values are ranging from negative infinity to positive infinity. So that's how we define the sine inverse, cosine inverse, and tan inverse. So again, the range of sine inverse is going from negative pi over 2 to positive pi over 2. Range of tan inverse is going from negative pi over 2 to positive pi over 2 without the corners. And the range of cosine inverse going from 0 to pi. And then how we define it, so we say that y equal sine inverse x if and only if x equal sine y. So that is what we need when we want to solve problems. So we can use this idea here. And again, we're going to say y equal cosine inverse x if and only if x equal cosine y. And you want to make sure that y is inside this special domain. Otherwise, you can write it like that. And then for the tan, we have y equal tan inverse x if and only if x equal tan y. So tan is easy, but the other two you have to be careful. You want to make sure that you have the y in the proper domain, proper range. Okay, so let's try to look at a problem and how we can use this idea to solve certain problems. So as the problem, let's look at a situation like this. So find the inverse function, range of f, and the domain and range of f inverse. So let's look at as the first problem, first part, like a problem like this. So let's say your fx is given as fx equal to sine x minus 1. Let's say the domain of x is negative pi over 2 to pi over 2. So you can see that these exactly match the domain that the range that we discussed for the f inverse function. So now if you look at the graph of the function, so what we have is here, so this is the sine function. So the graph going to be like this, so and then it's going to start here and then go like that. So that means it is negative pi over 2 to positive pi over 2. So that's a sine function. So going from 1 and negative 1. So that's how we restrict the domain. And you can see it is a one-to-one function in that particular domain. So that's the important part. So, so the answer, you can say that the function f is one-to-one on that domain, okay? The function f is one-to-one and has an inverse. Function. Because we know that if a function is one-to-one, there's inverse. So since there's inverse, we're going to find that inverse using the four-step method that we discussed earlier. So we're going to start with the function fx, which is 2 sine x minus 1. In the four-step method, what we can do was the first step, we're going to replace fx with y. So we write 2 sine x minus 1 and then replace x and y, or interchange x and y. So we're going to x can be 2 sine y minus 1, and then the goal is to solve for y. To solve for y, first thing we do, we can add 1 and then divide by 2. So we can first we add 1, and then what we can do is we can divide by 2. Then you're gonna get sine y. Now what we can do, we can look at the definition, and we can remember if we have x equals sine y, we can write this one as the inverse, because this is the implicit definition of the inverse function. So this means that this is if and only if we can write y equal sine inverse x. So inverse x, in this case not just x, so you can see this is x plus 1 over 2. So this is directly come from the definition, because if you can write x plus 1 over 2 equals sine y, this means that because since y is in the appropriate domain, this is exactly going to be the sine inverse function. So you can see that y equals sine inverse x plus 1 over 2. So that is how we can write it, because since, so this is the reason is, so you can see the major reason is y is inside the proper domain. So we can see y is inside pi over 2 to negative pi over 2. So that's the reason why you can write the inverse like that. But if it is not, if this is in a different domain, you cannot write it sine inverse x. We can do a problem like that at the end. What if it is not inside that particular domain? Okay, good. So we have that. So that means this is the inverse function. Now what we can do, we can write the inverse directly using the inverse notation. So then we can write it. So we can say the inverse function is, you can say f inverse x, so we can use this notation, f inverse x is sine inverse x plus 1 over 2. So that's the inverse function. So you can see we just use the four-step method and we can find it, but what we do is we use the definition of the inverse function, because we know that if you can write as x equals sine y, that means y equals sine inverse x. So that's the definition. Good. So the next one is we're gonna find what is the range of the original function f. So to do that, so we can say to find the range of f, we can say notice that sine is in between so you can say sine x is in between 1 and -1, then you can say if you multiply by 2, you're going to get -2 less than or equal to sine x less than or equal to. And then what we're going to do, we're going to subtract 1 from all three. Then you're going to see you subtract 1, so you're going to be -3 less than or equal to sine x -1. And you can see this is exactly y. This is exactly y. And then you can see this is less than or equal. If you subtract 1, it's going to be 1. So that means y is in between -3 and 1. So that is the range. So this implies that -3 less than or equal y less than or equal 1. That means the range of y is between -3 and 1. So you can see range of f. Range of f is, so we write the notation rf, which is going from -3 to 1. And then also we can use some other facts. So we know that to find the domain and range of f function, we know this idea. So for example, the domain of f inverse is exactly equal to the range of f. So that means that's what we just get. So it is -3 to 1, and the range of f inverse is equal to the domain of f. But you know that the domain of f, this function is going from -pi/2 to pi/2. That is one given. So this was given. This password given. Good. So that is how you solve the complete problem. So let's look at another problem like this. So as part B, we have fx equal 3 tan x minus 2, where x is in the domain -pi/2 to +pi/2. So and then if you look at the graph, so you can see we know the graph of tan inverse. So it's going to be in between -pi/2 to +pi/2. So the graph gonna look like this. So there's the graph of tan function. You can see this is a one-to-one function by the horizontal line test. So again, so we can say f is one-to-one. So the inverse exists. Inverse exists. So what we can do, and then we can use the four-step method to find the inverse. So we can use four-step method. To find the inverse. So again, so we can start with fx, which is equal to 3 tan x minus 2. So we replace fx with y, and then we switch the variables. So x equal 3 tan y minus 2. So the goal is to solve for y. So to do that, we're going to add 2 first and divide by 3. So you're going to add 2 and then divide by 3. So you're going to get tan y. Again, we know that the y is in the domain -pi/2 to pi/2. That means that's the appropriate domain. That means this is if and only if. So we can add the inverse function. This if and only if y equal tan inverse x plus 2 to 3, 2/3. That's by the definition. This is simply coming from the definition of the tan. So when you have tan, so what we do, we isolate the tan term. Once you isolate the tan term, we check the domain whether that's the right domain, then we can directly write the inverse. Good. So we can say the inverse of f is you can say f inverse x. So we can write using the f inverse notation. So it is simply tan inverse x plus 2/3. Good. So let's look at the range of this function. But we can see that for the if you look at the range of this function, we know that the tan is in between negative pi over actually tan is in between negative infinity to positive infinity because of it goes to infinities because of the asymptote. So we can say something like this. So we can say that so not that the tan function is in between negative infinity and positive infinity. So even if you scale, so you can say scaling by 3, scaling by 3 and shifting by 2, scaling by 3 and shifting by 2 does not change the range, does not change the range. You can see that it's because it's infinity. Since it is infinity, even if you multiply by 3, that's still infinity. Even if you add 2, it's still infinity. So that means the range does not change. So you can say thus, the range of the function is still negative infinity to positive infinity. So because of that, the domain of the f inverse function, means the range of f is still negative infinity to positive infinity. And the range of f inverse function, which is the domain of the f function, so you can see it is going from negative pi over 2 to pi over 2. That is what is given as an open interval. Okay, so that's about that. So let's do the last one. Let's do another one, a little complicated one. So how about this one? Let's say fx equal 2 cosine 3x plus 2, where the x ranging from negative 2/3 to negative 2/3 plus pi over 3. So you can see that why we pick, so you just pick a number and then do some manipulations here. So what happened, so if you use the starting value and the ending value, you can see if you plug in negative 2/3, what will happen, you can see that this term simply becomes 0. If you plug in negative 2/3 x, so you can see 3x plus 2 is simply 0. And if you plug in the other value, if you plug in this value, you can see that this 3x plus 2 simply becomes pi. So that means in this domain, if x ranges from in this domain, what will happen, 3x plus 2 ranges from 0 to pi. So that means it's going to get go through negative 1 to positive 1, the cosine values. But because of you multiply by 2, it actually ranges from negative 2 to positive 2. So we can see that. So if you look at the graph kind of looks like this. So this is like a little complicated graph. So you can see, so the values, the starting value is negative 2/3, and when you plug in negative 2/3, you can see it's going to be 2x plus 2 going to be 0. So that means if you plug in 0, cosine 0 is 1. Because you multiply by 2, you can see you multiply by 2. That means it's going to be 2. Starting value is 2. And you can see that if you plug in the middle value of these two, what will happen, you're going to see that, for example, when you plug in x equal pi minus 4 over 6, that's the middle value. And you can see that this is exactly at that value, it's going to be 0. So that's that value. And then the other side, you have negative 2/3 plus pi over 3. At that value is going to be negative 1. So that means the graph going to look like this. So this cosine graph shifted. So that's the graph you're going to get. So you can see it's going to go in the complete range from negative 1 to positive 1. So it will go from negative 1 2 positive ones. So the range is full range. So that's a graph of fx. So you can see it is a one-to-one function. So the answer f is 1 to 1 on the interval negative 2/3 to negative 2/3 plus pi over 3. So on that interval is 1 to 1. But if you pick a different domain, it may not be 1 to 1. So that means the inverse exists. So thus, the inverse exists. So we again use the 4-step method to find the inverse like this. So we can start with the function fx, which is 2 cosine 3x plus 2. We replace fx by y. So it's 2 cosine 3x plus 2. Switch the variable. So x equal 2 cosine 3y plus 2. Now the goal is to solve for y. So what we're going to do, we can divide by 2. So x over 2 equal cosine 3y plus 2. Now we can use the definition of the inverse function. So this is if and only if you can say cosine. So we can say 3y plus 2. What is the function you have here? So that's equal the cosine inverse. Once you isolate the cosine term, you can always do that. So you can write the cosine inverse x over 2. Now what we can do, we can solve for y. To do that, we can subtract 2 from both sides. So you can say 3y equal cosine inverse x over 2 minus 2, and then we divide by 3. To remove 3, we can divide by 3. So you can write this on y equal 1/3 cosine inverse x over 2 minus 2. So that is the inverse function. So we can write it like that. So the inverse function, the inverse is, we can say if inverse x, which is equals to 1/3 cosine inverse x over 2 minus 2. And in this case, it is very clear that the range of the function, original function, is going from negative 2 to 2. It's also clear from the graph. And the range of the f inverse function, which is the domain of the original function, which is equals to negative 2/3 comma negative 2/3 plus pi over 3, and the domain of the f inverse function, which is simply the range of the function, which is negative 2 to 2. So that's how you can find the range, domain, and the inverse function of that completed function. So I'm going to give you 2 examples as challenging problems. See whether you can find the inverse of those 2 functions, and if you can leave them in the description as a comment for this. So why don't you try these 2 questions? These are challenging. This is not easy. Let's see whether you can do this. So here you can solve these 2 challenging problems. So they're asking the same question: find the inverse of the following functions. And you can notice that this is not the standard domain for the inverse function. So that means you need to do some shifting to get this answer. And the same thing here, this is not the standard domain. So see whether how you can bring it back to this domain. So, and if you know how to solve them, you can leave them in the in the comment section.